Hello and welcome back to our next edition of Unit 2 videos discussing angles and lines. So before we get into that, I would love to tell you a joke because we haven't told one in a while. So why did the obtuse angle go to the beach? Anybody? Anybody? Because it was over 90 degrees. I hope you all appreciate how hard it was for me to find that laugh track. And I love this little husky. He's got the cute little face. All right, let's move on. Anyway, so we have a couple of things that more definitions that we want to talk about. We haven't really touched in on types of lines, and so please make sure as we are going that you are taking notes and you're getting the definitions written down. So the first thing is parallel lines. Now you probably have heard of these in the past, but parallel lines, they are coplanar, so they're sitting on the exact same plane. They are lines that never intersect. So you probably have worked with them on a coordinate plane, but now we're talking kind of generalized like this right here. We have a symbol to mean parallel. That's these guys right here. It's two lines right next to each other. So for example, AE is parallel to BF. That's kind of how you're going to read that. So AE, which is right here, is parallel to BF. Now what I want you to notice is on the lines, do you see this right here? We have some arrows. Those arrows are also telling us on the picture that they are parallel. Same thing for the second one, AD. AD is parallel to BC, but now do you see how it increases and there's now two of them? It's kind of like when we talked about congruence, where if these two lines were congruent and these two lines are congruent but they weren't congruent to each other, we would do one tick mark and two tick marks. It's kind of the same idea, but now with parallel lines. Okay, moving on, we got ourselves some skew lines. So you may or may not have heard of this before, but skew lines are non-coplanar, they are not parallel, and they do not intersect. We do not have a symbol for those as well. Okay, so taking a look at our example, we have AB, this line right here, it is skewed to CG. So you see how they're not going in the same direction. They are never going to touch. Visualize in the classroom or in the or at your house. Thinking about the creases where the ceiling and the walls intersect. That's really a good way to look at it. And if you want me to show you in the classroom more specific, please just let me know. But they are never going to touch. They are not parallel to each other. They're never going to be on the same plane, opposed to maybe like this line is maybe to that single point that exists, point C. That's on the same plane, but that's really all that is there. And then we also have ourselves parallel planes. Remember, we name planes using at least 3 points that are non-collinear. So for example, ABC. And we still use the same symbol, the parallel, the two lines right next to each other, and plane EFG. Okay. Now, raising segments, they can also be considered parallel or skew. We just went through and also I just specified for lines right now. All right, so here's an example. What I want you to be able to do is, assuming anything that looks parallel is parallel. So what I want to know is what segments are parallel to AB. So this is one that's going back and forth here. So some of them that might be obvious to you would be CD and EF. So this is on the same plane here, and this is on the same plane here. But what I want you to notice is that this guy right here, this line GH, it is also parallel to line AB. Even though there is not a plane that's drawn in there, I could say put a piece of paper right through the middle and it would touch both of these segments here. Okay, so all those segments are parallel, including the one that did not necessarily look like it. Okay, moving on, which segment is skewed to? I believe that should have been CD. Yep, that says segment CD right there. I'm sorry, that was covered up by the picture. So skew means it's never going to touch, it's not going to be parallel. So it couldn't be like CG or DH or GH, any of those, because they're touching or they are parallel. So in this one here, some skew ones would be this one across over here, this BF. We've got AE. We also have a couple others, EH. You see that? So even though H and D kind of are on top of each other, CD is going back and forth like this, but EG is not going the same direction. Same thing with FG on the back end there. Okay. Two parallel planes. We got a couple. We can do the top to bottom, left to right, front and back. Well, let's choose one of them. We got ABCD is parallel to plane EFGH. You could say DCG is parallel to ABF. There's another option, okay? What are two segments parallel to plane BCGF? So BCGF is the one along the back there. So now we're looking for two segments that are parallel to it, so it has to be on a parallel plane. So we really have 4 of them all together that make up that Two examples would be AD and DH. We could have also said EH and AE. Okay. All right, so let's move on. We're going to get now more specific with some things because we're dealing with a lot with our parallel lines and such. We have things that are called transversals. So there are lines that are going to be intersecting more than one. They are called transversals. And this is a line that's going to intersect two or more coplanar lines at distinct points. There are 8 angles that are formed by the transversal, we call it T, and 2 lines M and L. So here is our example of 2 lines L and M, as you see below. So when you're writing this definition, get this picture in right below it or next to it in some way. And the transversal would be this line here, T. It is intersecting these 2 lines at distinct points here and here. And as you can see, we've got 8 angles formed all together. Now, there are 2 sides to this. We have the interior and the exterior. Angles 3, 4, 5, and 6 are found inside, in between the 2 lines where the transversal is, while 1, 2, 8, and 7 are found in the exterior, so outside the 2 lines. That is really crucial for you to understand because we're going to start using the terminologies interior and exterior in some more definitions, and if you don't know the difference, you're going to have a little bit of a tough time, okay? So let's start talking about some specific angles. The first one is our alternate interior angle. So we're going to pretty much use the same exact picture every time, this guy here. So you really need to draw it once, or really it's the same picture as this one here. So you don't need to draw it every single time. You just need that one time. All right, so we have our first definition with the angle pairs. It's called alternate interior angles, and these are non-adjacent. So they're on not next to each other, and they are inside angles, and they're opposite sides of the transversal. So alternate means opposite side of the transversal, and interior. So an example of that would be angles 3 and 5. They are called alternate interior, and 4 and 6. They are also called alternate interior. Now, the second one we have is called same side interior. So the big thing here is same side. Okay, we can also call it consecutive. Okay, that's another term that can be used for these. But alternate was on opposite sides, so same side, they're going to be on the same side of our transversal, or like I said, consecutive interior. So an example of that would be angles 3 and 6. Another example would be 4 and 5. They're on the same side on the inside. Okay. Moving on, we have corresponding angles, and these are on the same side of the interior, but they're in the same position. Now, if I were to say cut out these 4 angles, and I were to scooch it down so this little point here is sitting right on top here, we would be able to line up our corresponding. It's in the same position. Top left, bottom left, and the same thing with the other side there. Those are corresponding angles. Now what I want you to notice is that these lines are not parallel. I didn't do anything with specifying that these had to be parallel. These angle pairs still exist, and I can name them. They do have special properties when they do get to become parallel, and we'll get to that in just a moment. All right, next one is alternate exterior. So corresponding was on the same side, but alternate exterior is on opposite sides. So it's the same idea as the alternate interior angles, except now we're on the outside of the 2 lines L and M. So in this one here would be angle 1 and angle 7, and this one here would be angles 2 and 8. So with these comes some postulates and theorems, which means let's get this written down where you put your postulates and theorems. So the first one is the corresponding angles postulate. So if 2 parallel lines are cut by a transversal, then the pair of corresponding angles are congruent. So again, thinking back to this picture with the corresponding, that means angle 1 and angle 5 would be congruent if those 2 lines were parallel. All right, continuing on, the alternate interior angles, they are also going to be congruent. Okay, so corresponding angles are congruent. The alternate interior angles are going to be congruent. The alternate exterior angles are also going to be congruent. The only one that's going to be different is the same side interior. That's the only one where it's supplementary. And what does that mean? 180 degrees. So pretty much everything is congruent except for the same side interior. Those are the only ones that are different. So let's take a look at an example on how this is used. So for here we have, our goal here is to find what the measure of x is. So that's this guy right here. So let's see what I have. Well, I have this angle 115 degrees. There's no direct relationship between these. These are not alternate interior. These are because one's out, one's in. These are not corresponding because it's on different sides of this guy here. So what we want to do is try to get one so it is one of those pairs. So what I'm noticing here is this pair right here, and we've talked about these a little bit before. Those are vertical angles, and what we know about vertical angles is they are equal. So what that means is angle 4 has to be 115 degrees. So now I know that I have my same side interior here. Do you see how these are on the inside? I know that they're parallel because of these markings here. Same side, inside, consecutive interior. This is the only one that was different than the others. These are adding up to 180. They're supplementary. So I know the angle 4 plus the x plus 5 equals 180. And I'm going to substitute that 115 in. So 115 plus x plus 5. We're in algebra town now. Combine like terms, subtract from both sides. I know that the value of x is equal to 60. Okay, now I can put that back in and get this as 65. And I already knew that this was 115, so on and so forth. Okay, so this is a case where we're going to add them up to 180. Remember I said way back when that you really have two things. You're either going to add them up or set them equal. This is a case where we're adding them up. However, in this one with our very pretty rainbow, how many of you love to go outside during the rain and we can get to see some really pretty rainbows once the sun gets up? But when sunlight enters a drop of rain, different colors leave the drop at different angles, and this is what's making a rainbow. So for violet, the measure of angle 2, which is this right here, so the rays of sun are what's in yellow here, okay? The purple is what we see. This angle is formed between the ray of sun and the angle that we're looking at it. So this angle 2 is 40 degrees. I want to find the measure of angle 1. So like I said before, we want to think back, okay, my two options really usually are add them up or set them equal. And so we had those theorems, and the first one was that postulate. And I'm saying, okay, what kind of angles are these? Well, these are clearly on the inside of the two yellow rays, so they're in between, which means we're looking at interior. So our options are alternate interior or consecutive interior. Well, they're not on the same side of this transversal. This violet here is transversal, so that means alternate. Alternate interior means equal. So since they are equal, that means the measure of angle 1 has to also be 40 degrees. And again, it's all based upon when I ask you how do you know or to justify, I just want to know what theorem it is. So for this one, it would be the alternate interior theorem. I hope this was a good intro, and for some of you, maybe a review to the different types of angle relationships that we have. Please make sure that you have written down all the notes and the definitions and ask any questions, and go ahead and get started on your practice.